Hi, hello, I'm Kiran Kumar from Nature of Physics. This is the friction part 3 video student. Part 1 basic friction, second static and limiting friction, and third video this is kinetic friction and rolling friction. Okay student, now I'm going to discuss about the definition. See, when a body slides over the another body surface, the frictional force present in between the two surfaces in contact is known as the kinetic friction or dynamic friction or sliding friction student. See, this is a body slide over the surface of the another body student, okay, and that is we can take as a floor also. So now here F is the applied force and opposite direction frictional force developed, and upward direction normal reaction that is perpendicular to the surface, and downward direction weight of the body is mg acting student. So that here kinetic friction is directly proportional to the normal reaction student. I can write there Fk is directly proportional to the normal reaction, and Fk which is equal to mu k into n student. This is equation number 1. Now Fk which is equal to mu k into mg student, because of n is equal to mg, both are equal in magnitude and opposite in direction. Okay student, now mu k is the coefficient of kinetic friction, okay, mu k which is equal to coefficient of kinetic friction. Okay student, and mu k formula also we can write here, mu k which is equal to Fk divided by n. I wrote this equation from equation number 1 student. And then continuation, rolling friction, when a body roll over the surface of the another body, then the frictional force is developed. Frictional force present in between the two surface in contact is known as the rolling friction. A person is pulling here student with a force F, horizontal force, and opposite direction rolling friction is developed, and normal reaction is perpendicular to the surface, mg is acting downward direction. So rolling friction depend on the area of contact student, and rolling friction depend upon the radius of the rolling body. So rolling friction is inversely proportional to the radius of the body, and rolling friction is directly proportional to the normal reaction. Fr directly proportional to n student. So Fr is equal to mu r into n student, where mu r is the coefficient of rolling friction. Rolling friction. Yes student, and continuation, this is taken as equation number 1 student, but normal reaction is equal to mg, both are equal in magnitude and opposite in direction. So rolling friction which is equal to mu r into n replacing by mg student. From this equation I can write mu r which is equal to Fr divided by n. This is equation number 2 student. Coefficient of friction has no units and dimensions because of it is the ratio of same physical quantity. Okay, and one thing we can notice that here the frictional forces are there, the frictional force, kinetic friction, next rolling friction and static friction. Static friction is greater than to the kinetic friction, and kinetic friction is greater than to the rolling friction student, because of the body at rest initially. So we have to apply the more force, that is static friction is greater than to the kinetic friction and rolling friction student, and kinetic friction is greater than to the rolling friction. Same we can write here, mu s is greater than to the mu k is greater than to the mu r. Coefficient of static friction is greater than to the kinetic friction, and coefficient of kinetic friction also greater than to the rolling friction student. This is clear information about the kinetic friction and rolling friction student. Please do like and comment and subscribe my channel. Thank you students.